Hello friends, welcome to my another video on software testing basics. So here I have a PDF with some of the software testing questions. So I'll be just walking you guys through the PDF. So it's like the first question is like, can you please explain the PDCA cycle and where testing fits in? So actually, the PDCA is all about plan, do, check, and act, and all those things. So like you can see, there will be a plan phase, there will be a do and execute phase, then there will check phase, and there will be a act phase. So actually it's like the testers do the check part of the cycle mostly. Second question is all about what is the difference between white box, black box, and gray box. So black box is a testing strategy based solely on requirements and specification, whereas white box testing is a testing strategy based on internal paths, code structures, and all those things. So if you have knowledge on both black box and white box, then we call it as gray box. And in most scenarios, white box testing is done by developers as they know the internals of the application. So what is the difference between a defect and a failure? When a defect reaches the end customer, it is called as a failure. And the effect is detected internally, it is called as a defect. So what are the categories of the defect? So one of them is wrong, that the requirement have been implemented incorrectly. Then second is the missing, that the requirement given by the customer, there was something missing. And then are extra, the requirement incorporated in the product but was not given by the end customer. So what is the difference between verification and validation? Verification is a review without actually executing the process, while validation is checking the product with actual execution. So how does testing affect risk? So risk can be only be controlled in different scenarios, but it cannot be eliminated completely. So actually here you can see the verification and validation of it, and when a defect, it can be converted into risk without testing. Defect testing, then minimal risk. Does an increase in testing always improve the project? No, an increase in test does not always mean improvement of the product. In real test scenarios, only 20% of test plans are critical from a business angle. So you can see a testing cost curve where we have the number of tests against number of defects, and that is the optimal point. How do you define a testing policy? So actually it's like what are the policies that you should be included in a test plan and all those things. So we have the definition. The first step any organization to do is define one unique definition for testing, and then how to achieve that definition that we have given, and then how we evaluate that we have reached that definition or the goal that we set, and some of the standards. Should testing be done only after the build and execution phase are complete? No, actually it is not like that. Testing can be done at any phase. In traditional waterfall model, we follow this requirement design, code and build testing and maintenance, but it's not always the correct approach. So you can see here like a modern way of testing. Are there more defects in the design phase or in the coding phase? So actually on an average, 60% of defects occur during design and 40% during execution phase. What kind of input do we need from the end user to begin proper testing? So first is the acceptance plans from the end user, then the requirement documents, and also the risk section of the project, and also the customer should give the proper data. What is the difference between a latent and masked defect? A latent defect is an existing defect that has not yet caused a failure because the exact set of conditions were never met. A masked defect is an existing defect that hasn't yet caused a failure because there's another defect is preventing that code from being executed. So that's it. Then, so it's an example of how where this latent and the masked defect. A defect which could have been removed during the initial stage is removed in a later stage. How does this affect cost? So it always says a defect, if identified and removed during the requirement and design phase, is most cost effective, while a defect removed during maintenance is 20 times costlier than during the requirement and design phase. So here you can see cost of defect increases with each phase. Can you explain the workbench concept? A workbench is a way of documenting how a specific activity has to be performed. A workbench is referred to as a phase, steps and tasks. So there are 5 tasks for every workbench. It starts with input, execute, check, production output and rework. So there is a picture representation of these phases in a workbench. And this is also how it happens in a software cycle. So we have requirement, design, execution, testing, deployment, maintenance. So we have the requirement phase workbench, design phase workbench, execution phase workbench, testing phase workbench, deployment phase workbench, and finally the maintenance phase workbench. What's the difference between alpha and beta testing? So alpha and beta has different meaning to different people. So alpha testing is done at the development side, where the beta testing is done at the customer end. So what is defect cascading, or how one defect leads to another defect? Defect cascading is a defect which is caused by another defect. That means one defect triggers the other defect. So here is an example that's for the defect cascading. What is usability testing? Usability testing is a testing methodology where the end customer is asked to use the software to see if the product is easy to use to the customer's perception and task type. What are the different strategies for rollout to end users? So there are 4 major ways. One is the pilot phase. Then the next one is the gradual implementation. Then we have the phased implementation. And the final one is the parallel implementation. So actually there's a picture representation of the different launch strategies. Can you explain requirement traceability and its importance? So if the tester gets involved right from the requirement phase, then requirement traceability is one of the important reports that can details what kind of test coverage the test case have. So actually you can see how the requirement traceability is actually shown in the a picture representation. What is the difference between pilot and beta testing? The difference between pilot and beta testing is that pilot testing is nothing but actually uses the product, and in beta testing we do not input real data, but it is installed at the end customer to validate if the product can be used in production. How do you perform a risk analysis, or how do you conclude which section is most risky in your application? The first step is to collect features and concerns from the current documentation and data available from the requirement phase. Once we have listed the features and concerns, we need to rate the probability or likelihood of the failure in these features. Once we have rated the failure probability, we need to rate the impact. Impact means if we make changes to the feature, how many other features will be impacted. We also need to define the master priority rating table depending upon the impact and probability ratings. Using the priority rating table, we have defined priority for the following listed features. Depending upon the priority, you can start testing those features first. Once the priority is set, you can then review it with your team members to validate it. So here it's an example. And actually we have a testing analysis and design picture representation also. What does entry and exit criteria mean in a project? Entry and exit criteria are a must for the success of any project. If you do not know where to start and where to finish, then your goals are not clear. By defining exit and entry criteria that the customer, you define your boundaries. So actually you can see that in the requirement document or the acceptance test plan is the entry criteria, and the exit criteria will have the acceptance test plan. On what basis is the acceptance test plan prepared? So one is the requirement document, second is the input from the customer, and the third is the project plan. So these are some of the criteria for acceptance test plan. What is the relationship between environment reality and test phases? Environment reality becomes more important as test phases start moving ahead. For instance, during unit testing, you need the environment to be partly real, but the acceptance phase, you should have 100% real environment. So here is a graph which says unit integration system and acceptance. So at the acceptance, we should have the environment almost fully ready. What are the different types of verification? Or what's the difference between inspection and walkthrough? So actually, verifications are basically of two types, walkthrough and inspections. A walkthrough is an informal form of verification that you can ask your colleague to do a informal walkthrough and all those things. But inspection is a formal procedure and official. So you can see verification in a pictorial representation. Can you please explain regression testing and confirmation testing? Regression testing is used for the regression defects. Regression defects are defects occur when the functionality which was once working normally has stopped working. That is all about regression. So confirmation testing is to test if the defect is removed. It is very possible because of this defect or change to the application that the other sections of applications are affected. So to ensure that the whole application is working fine, we do the regression testing. What is coverage and what are the different types of coverage techniques? So coverage is a measurement used in the software testing to describe the degree to which the source code is tested. So mainly we have three types of coverage: statement coverage, decision coverage, and path coverage. How does a coverage tool work? So while doing testing on the actual product, the code coverage testing tool is run simultaneously. While the testing is going on, the code coverage tool monitors the executed statement of the source code. And when the final testing is completed, we get a complete report. So that's all about the coverage tool. What is configuration management? So configuration management is the detailed recording and updating of the information for hardware and software components. So actually it can be tracking of changes for software documents such as requirements, design, test case, etc. So can you explain the baseline concept in software development? Actually, baselines are logical ends in a software development lifecycle. For instance, let's say you have a software whose release will be done in phases. So in phase 1, phase 2, etc. So you can baseline your software product after every phase. So in the picture representation you can see the version you have a new feature added, then you have the version 2 where you have removed some defects and all those things. What are the different test plans documented in a project? So we have something called central or project test plan. Then we have the acceptance test plan. Then we have the system test plan. Then we have integration testing. And finally we have the unit testing. So how do test documents in a project span across the software development cycle? So actually you can see that the central test plan is in requirement design, execution, testing, development and maintenance, and the acceptance test plan actually from half of the requirement cycle till the end. Then we have the system test plan from design phase. Then we have integration test plan from the execution phase, and the unit test plan also from the execution phase. So can you please explain inventories, or how do you analysis and design for testing projects? Can you please explain calibration? So following are the three important steps for doing analysis and design. First one is the test objective. Then we have the inventory. Then we have the tracking metrics. So like in the test objective we have types of policies, error checking, features, speed, and the inventory we have something called add new policy, change or add address, delete a customer. So those are some of the examples. So here we have an inventory tracking matrix which tracks all the inventory details. Which test cases are returned first, white box or black box? Normally the black boxes test cases are returned first and white box test cases later. In order to write black box test case, we need the requirement document and design of the project plan. So white box test cases cannot be started in the initial phase of the project because they need more architectural clarity which is not available at the start of the project. Can you please explain cohabiting software? When we install the application at the end, it's very possible that on the same PC and other applications are also exist. So it's also very possible that those applications share common DLLs, resources, etc. with your application. There is a huge chance in such situation that your change can affect the cohabitating software. So the best practice is after you install or alter any changes, tell other application owners to run a test cycle on their application. What impact ratings have you used in your project? So we have something like minor, major, and critical. What is a test log? The IEEE standard 829-199 defines a test log as a chronological record of relevant details about the execution of test case. It's a detailed view of activity and events given in a chronological manner. Explain SDLC, or what is waterfall model, Big Bang waterfall model, phased waterfall model, and all those things. So we have something called like we have so many SDLC like waterfall, Big Bang, phased, iterative, spiral, and incremental. So let's start with waterfall. So actually the waterfall model, we have something called a requirement stage, design stage, build stage, test stage, and deliver stage. And then we have something called phased waterfall model. Then we have iterative model, incremental model, spiral model, evolutionary model, and finally the V model. So actually we have a V model in the sense actually the development and QA goes side by side. So in the V model we have the unit testing, the integration testing, the system testing, etc. So what is the difference between system and acceptance testing? So acceptance testing checks the system against the requirements, whereas the system testing checks that the system was specified, has been delivered or not. Which is the best model? So actually we have gone through all the models, but actually one complete model can fulfill entire project management. In some projects, tailored models are proven to be the best. So the waterfall, iterative, evolutionary models, and so can fit in any real-time projects. If it's a pure testing project, then the V model is the best. So what group of teams can do software testing? So we have something called isolated test team. Then we have something called outsource. Then inside test team, developers as testers, and QA/QC team. So with that, I complete this chapter 1. So we are going to the chapter 2, testing techniques. So can you please explain boundary value analysis? So what is a boundary value in software testing? For example, a bank application can withdraw an amount of 25,000 and a minimum of 100. So in boundary or value, we only test the exact boundaries rather than hitting in the middle and all those things. So that's all about the boundary value. So we have something called then equivalence partitioning. So in equivalence partitioning, we identify inputs which are treated by the system in the same way and produce the same result. So here I have the example for boundary value and equivalence partitioning. So boundary value, as you can see, you have the maximum and minimum, and we will be considering one or two values based within that limit. In the equivalence partitioning, actually we will be equally partitioning the test cases so that there will be two results, and test case 1 and 2 will be for result 1, and test case 3 and 4 will be for the result 2. An example of the equivalence partitioning. So actually you can see we have 20 and 2000. So we have one test case for less than 20, then 30, then 100 and 2000. Can you explain how the state transition diagram can be helpful during testing? So this is a sample state transition diagram. Issue check. So it's a transaction is happening. Check ready to be deposited. check deposited, then his check is cleared. If the check is deposited and the check bounce, so those are the other states in this scenario. So we can see that the states goes to a test case and transaction also considered as a test state, and the state and transaction can also be considered as a test case. Can you please explain random testing or monkey testing? So random testing is also called as monkey testing. In random testing, data is generated randomly, often using a tool. So that is the simple definition of random testing or monkey testing. So random testing has the following weakness. They are not realistic. Many of the tests are redundant and unrealistic. You will spend more time analyzing result. You cannot recreate the test if you do not record what you are doing with the testing. What is negative and positive testing? So when you give an invalid input, whatever error you are getting, that is a negative test. And with what valid input you are giving and the expected result, that is known as positive test. Can you explain an exploratory testing? Exploratory testing is also called ad hoc testing, but in reality, it's not completely ad hoc. Ad hoc testing is actually unplanned, unstructured, maybe even an impulsive journey through the system. But exploratory testing is simultaneous learning, test design, and test execution. Because actually, it is done to extend that the tester proactively controls the design of tests as those tests are performed and uses information gained while testing to design best test. So that's all about the exploratory. What are semi-random test cases? As the name specifies, semi-random test cases is nothing but controlling random testing and removing redundant test cases. So what we do is perform random test cases and equivalence partitioning to those test cases, which in turn remove the redundant test cases, thus giving us semi-random test cases. What is an orthogonal array, or can you please explain a pairwise defect? So orthogonal array is a two-dimensional array in which we choose any two columns in the array and all the combinations of numbers will appear in those columns. The following figure shows a 3 raised to 4 orthogonal array. In this, the number 9 indicates that it has 9 rows, and the number 4 indicates that it has 4 columns, and 3 indicates that each cell contains 1, 2, or 3. And you can choose any column, so let's choose 1 and 2. So it has 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. So as you can see, this value covers all the values in array. So compare these values with combination of column 3 and 4 and they will fall in the same pair. This is applied in software testing, which helps us eliminate duplicate test cases. So this is another example of orthogonal array in actual testing. Can you explain decision tables? As the name suggests, they are tables that list all possible inputs and all possible outputs. So at the bottom of the picture you can say test case 1, if married gets a discount. Test case 2, if student gets a discount. If not married, no discount. If not student, no discount. So that's a discount decision table. So from this condition and rule only we derived this decision table. How did you define severity ratings in your project? So there are these are some of the severity ratings. So showstopper, application continues with severe defects, application continues with unexpected result, some suggestions. So severity 1, as you know, is a showstopper. Severity 2, as there is a defect but it's not a showstopper. Severity 3 is like application continues but with unexpected result, and severity 4 is like some cosmetics defects, but those are some suggestions. So now we are into the third chapter, the software process. So what is a software process? A software process is a series of steps used to solve a problem. So actually we have a small diagram which explains the software process, like process series of steps, solve a problem, identify the risk, prioritize the risk, analyze the risk, and then mitigate the risk. So that's all about this diagram is explained here. So what are the different cost elements involved in implementing a process in an organization? So some of them are salary, then the consultant fees, then the training cost, and the tools cost. What is a model? A model is nothing but best practices followed in industry to solve issues and problems. What is a maturity level? The maturity level specifies the level of performance expected from an organization. Can you please explain the process areas in a CMMI? So a process area is the area of improvement defined by the CMMI. Every maturity level consists of process areas. A process area is a group of practices or activities performed collectively to achieve a specific objective. So in the process area, we have project planning, configuration management, and requirement gathering. Now, can you explain tailor? So as the name suggests, tailoring is nothing but changing an action to achieve an objective based on some conditions. So whenever the tailoring is done, there should be adequate reasons for it. So here is an example of tailoring, like contract to be signed in hard copy, tailoring. Contract can also be signed through email. So in order to achieve some objective, we are setting some conditions. So we are moving on to the chapter 4, CMMI. So what is CMMI and what's the advantage of implementing it in the organization? CMMI stands for Capability Maturity Model Integration. It is a process improvement approach that provides companies with essential elements of an effective process. So there are something called system engineering, software engineering, and then integrated product and process development. So IPPD is a systematic approach that achieves a timely collaboration of relevant stakeholders throughout the life of the product to better satisfy customer needs, expectations, and requirements. And there is one more, like software acquisition. So these are the four major process that we handle in the CMMI. What is the difference between implementation and institutionalization? So implementation is just performing a task within the process area, whereas institutionalization is an output of implementing the processes again and again. So difference between is in the implementation. If the person who implemented the process leaves the company, then the process is not followed. But if the process is institutionalized, then even the process leaves the organization, the process is still followed. So what are the different models in CMMI? So there are mainly two types of model. One is the staged and one is the continuous. The stage in this which the maturity level organizes the process areas. In the continuous, the capability level organizes the process areas. So here is an example of stage and continuous model. So here we have a stage representation and a continuous representation. So in the stage representation, the maturity level is divided into process areas. Then we have specific goals. But in the continuous representation, there is a process area. Then we have some specific goals and generic goals. Then we have a specific practice and generic practice. Can you please explain the different maturity model in a staged representation? So there are 5 maturity models. So the maturity level 1 is the initial. So in this level, everything is ad hoc. In the level 2, we have managed. In the managed level, basic project management is in the place. Then we have the third level, which is defined. So to reach this level, the organization should have already achieved level 2. So in the previous level, the good practices and processes were done at the project level. But in this level, all the good practices and processes are brought to the organization level. Then we have the maturity level 4, that is quantitatively measured. So you should have already achieved level 2 and 3. And in this level, the more statistics and other quantitative techniques are used. And finally, we have the optimized level. So in order to achieve this level, you should have level 2, 3, and 4 achieved in your organization. And in this level, the processes are continuously improved based on the understanding of common causes of variation within the processes. So here we have a picture representation of all the maturity level. Now we will be talking about the capability levels in a continuous representation. So actually it's same as the staged model, but the arrangement is quite different. So the capability level 0 is incomplete. That it means that any generic or specific practice of capability level is not performed. Next level, we are performing some practices. So it's called performed. So and actually the performance may not be stable, and the probably does not meet objectives such as quality, cost, and schedule. But still, the task can be done. Then we have something called managed. So in this managed, actually the processes are planned properly, performed, and monitored and controlled to achieve a given purpose. Then we have the defined. So the defined process is a managed process that is tailored from an organization standard. So tailoring is done by justification and documenting guidelines. And finally, we have the level 4, that is quantitatively managed. So it's a defined process which is controlled through statistical and quantitative information. So in the diagram we have CL0 incomplete, then performed, managed, defined, quantitatively managed, and then optimized. And this in the optimization process is a quantitatively managed process where we increase the process of performance through incremental and innovative improvements. So which model should be used and under what scenarios? So staging defines an organization process implementation sequence. So actually staging is a sequence of targeted process areas that describes a path of success improvement the organization will take. So actually if you want to do some process improvement the organization is going to take, then it will be preferred to use the staged model. But if when your organization should only concentrate on a specific process area that you would like for the continuous model, that if you want your organization to have a specific plan and to achieve not only the specific process but also any linked processes, then you should go for the continuous model. How many process areas are present in CMMI and what classification do they all fall in? Actually, there are around 25 process areas in CMMI, and actually it is divided into 4 major sections. The first one is the process management, the project management, the engineering, and support. So in the picture ladies, it gives all the process areas. So can you define all the levels in CMMI? So we have the level 1 and level 2. So level 1 is an ad hoc process in which the people have created a personal process to accomplish a certain task. In maturity level 2, individual shares their lessons and best practices, which leads to devising preliminary process at the project, and in some cases it also moved to the organization level. Then level 2 to level 3. In level 2 we have the good practices and all those things. So the biggest difference between level 2 and level 3 is the good practices from the project that are bubbled up to the organization level. Then we have level 3 to level 4. So level 4 is all about the numbers and the statistics. Then we have level 4 to level 5. So level 5 is all about improvements as compared to level 4. So what different sources are needed to verify authenticity for CMMI implementation? So actually we have something called the instrument. So instrument is a survey or the questionnaire provided to the organization and the project or individuals. Then we have the interview. So the interview is a formal meeting between 1 or 2 members of the organization. And the documents. The documents is a written work or something that serves as an evidence. So can you please explain the SCAMP process or how the appraisal is done in CMMI? The SCAMP stands for Standard CMMI Appraisal Method for Process Improvement. So it's based on providing the rating. So based on we have class A, class B, and class C, all those things. So class A, this is the only method that provide a rating and you get you a CMMI certificate. Class B, so actually it only requires only two sources of data, that is interviews and other documents. And Class C actually it requires only one source. One source of data, either interview, instruments, or documents. Which appraisal method is the best? So normally organization uses a mix of these classes. For the first strategy, use Class B to initiate a process improvement plan. After that, apply Class C to check the readiness for Class B or Class A. The second strategy is use Class A appraisal first. So from Class A, we will get the aggression of the weakest against across the organization. Then we can create a project improvement plan. Then we can use a Class B appraisal to see if you are ready for Class A appraisal. Then the third strategy is use Class A to initiate an organization level process. So actually the process improvement plan is based on the identifying the weakness. The Class B appraisal should be performed after 6 months to see the readiness of for the second Class A appraisal rating. So what is the importance of PII in SCAMP? So PII stands for Practice Implementation Indicators. So actually from the diagram you will be able to understand something like PII type. There is direct work product, indirect work products, and affirmation. Then what are the organizational evidence for that, and what are the notes? So that's all about this PII. The implementation of CMMI in one of the key process areas. So actually there is a example of how we have implemented the CMMI in one of the key process areas. So this is a SAM process area mapped. So CMMI processes. Determine the acquisition type. Select suppliers. Establish supplier agreements. Review products. Execute supplier agreement. Accept acquired products. Transition products. So then let's move on to the process areas and goals and practices. So actually each process area is defined by a set of goals and practices. There are two categories of goals and practices, that is generic and specific. Generic goals and practices are part of every process areas. Specific goals and practices are specific to a given process area. So based on the goals and practices, actually we have the process areas. Then we have the question analysis and resolution, support process area at maturity level 5. Then the specific practices. Then we have the configuration management. The configuration management is to establish and maintain the integrity of the work product using configuration identification, configuration control, configuration status accounting, and configuration auditing. Then we have something called DAR, decision analysis and resolution. So it's to analyze the possible decisions using formal evaluation process that evaluates identified alternates against established criteria. Then we have something called integrated project management. So it's at maturity level 3. So it is to establish and manage the project and the involvement of relevant stakeholders according to the integrated and the defined process. Then we have something called integrated supplier management. So it is to proactively identify sources of products that may be used to satisfy the project's requirement and to manage selected suppliers while maintaining a cooperative project supplier relationship. So then we have something called the integrated teaming. Then we have measurement and analysis. Then we have organizational environment for integration. Then organizational innovation and deployment. Organizational process definition. Organizational process focus. Organizational process performance. Organizational training. Protect integration. Project monitoring and control. Project planning. Process and product quality assurance. Quantitative project management. requirement development, requirement management, risk management, supplier agreement management, technical solutions, documentation validation, verification. So we are into the next chapter. What is Six Sigma? Six Sigma is a statistical measure of variation in a process. So we say that a process has achieved Six Sigma if the quality is 3.4 dpm, that is defect per million opportunities. Can you explain the different methodology for the execution and the design processes stages in Six Sigma? So the main focus of the Six Sigma is to reduce defects and variation in the processes. So we have DMAIC and DMADV, which are the models that we use in the Six Sigma initiatives. So it's for DMAIC stands for define, measure, analyze, improve and control. And DMADV stands for design, measure, analyze, design and verify. So what are executive leaders, champions, master black belts, green belts and black belts? So executive leaders are the main people who actually decide that we need to do Six Sigma or do not. They promote it throughout the organization and ensure commitment of the organizations. And then the champions. Champions are normally senior managers of the company. So these people promote Six Sigma mainly between the business users. Now then we have the master black belts. This role requires the highest level of technical capability in Six Sigma. Normally, organizations that are just starting up with Six Sigma will not have the master black belt. So normally, outsiders are recruited. Then we have the black belts. So black belts lead a team on a selected project. It has to be showcased for the Six Sigma. They are mainly responsible for finding out variations and seeing how these variations can be minimized. Then we have the green belts. So the green belts assist the black belts in their functional areas. They are mainly in project and work part-time on Six Sigma implementations. So they apply Six Sigma methodologies to solve problems and improve processes at the bottom level. So these are the players of, so we have executive players, ensures commitment within the organization for Six Sigma. Then we have the champions, so remove hurdles of black belt. Then we have master black belt, so a trainer, mentor, or a guide. Then we have the black belt, and finally the green belts. So what are the different kind of variations used in Six Sigma? So when we talk about the variations, it's all about the difference between the measurements. So we have mean, medium, mode, and range. So when we talk about the mean, so in the mean measurement, the variation measured and compared using the average techniques. So in the median, so median value is a midpoint of our range of data. Then we have the range. So range is nothing but the spread of values for a particular data range. And finally we have the mode. So mode is nothing but the most frequently occurring value in a data range. So what is standard deviation? So the most accurate method of quantifying variation is by using standard deviation. So it indicates the degree of variation in a set of measurements or a process by measuring the average spread of data around the mean. So it is more complicated than the deviation process discovered in the previous question, but it gives the accurate information. So we have the standard deviation formula with the observed value, the mean of all observed value, the number of observation, and sum. So there's a step 1 to calculate the standard deviation. Then we have the step 2. Then we have the step 3. And finally the step 4, we will take the square root of the value that we got in step 3. So what is fishbone or Ishikawa diagram? So there are many situations where we need to analyze what caused the failure or problem in a project. The fishbone or Ishikawa diagram is one of the important concepts which can help you to find the root cause of the problem. So fishbone was conceptualized by Ishikawa. So in honor of his inventor, the concept was known as Ishikawa diagram. So the main bone is a problem where we need to address to know what caused the failure. And then, so actually the following fishbone is constructed to find what caused the project failure. So then we have taken 4 main bones are input like what we have in the diagram. And finally we will, so actually then now once diagram is drawn, the end bones of the fishbone signifies the main cause of the project failure. And then we will find out with some outcomes which can improve the or which can prevent this failure. Then moving on to the next chapter, which is a metrics. What is meant by measures and metrics? Measures are quantitatively unit defined elements, for instance hours, a kilometer, etc. So measures are basically comprised of more than one measure. Can you please explain how the number of defects are measured? So number of defects is one of the measures used to measure test effectiveness. So the number of bugs that originally existed significantly impacted the number of bugs discovered, which in turn gives a wrong measure of the software qualities. So all defects are not equal, so defects should be numbered with a criticality level to get the right software quality measures. So the number of defects phase wise and the number of defects module wise, we have get a picture representation. And then finally the number of figures based on the priority or the severity. Can you please explain how the number of production defects are measured? So this is one of the most effective measures. The number of defects found in a production is recorded. The only issue with this measure is it can have latent and masked effects, which can give us the wrong value regarding software quality. So what is defect seeding? So actually defect seeding is a technique that was developed to estimate the number of defects resident in a piece of software. It's an often technique. So insert a defect in the code, run the application. Is the defect detected? If it is yes, then pass. If it is no, then it's failed. So actually you can see the seed ratio is equal to number of seed bugs found by total number of seeded bugs. So you can see they found 30 defects, but the total bugs is 70. So it's like the 42% is the seed ratio. Then the total number of defects is number of defects found by seed ratio, and it will give the total number of defects. And the estimated defects still present is it's like the total number of defects minus the total number of defects found. So which will be like the total number of estimated defects still present is 220. So what is DRE? Defect removal efficiency. So defect removal efficiency is a powerful metric used to measure test effectiveness. From this metric, we come to know how many bugs we found from the set of bugs which could have found. So following is a formula for calculating the DRE. So number of bugs while testing divided by number of bugs while testing plus number of bugs found by user. But the success of the defect removal efficiency depends on several factors like severity and the distribution of bugs must be taken into account. Then how do we confirm when the customer has found all the bugs? Can you explain unit and system test DRE? So DRE is also useful to measure the effectiveness of a particular test such as acceptance, unit or system testing. So actually the below figure give more details on so defect injector and removal per phase. So consider that we have 100 defects in found in requirement phase and 20 are removed, so 80 defects. So similarly 20 are found in design and 10 are removed. So design in there is 80 and requirement there are 90. So like that we go to execution, system test, acceptance and production. So this is how we calculate the defect injector and removal for this phase. So actually DRE is number of bugs while testing by number of bugs while testing plus number of bugs found by user. So totally it will be like 90 by 140.64. So if you are going to find it out for the system testing, then the number of defects found using system testing. And then if it's for unit testing, then number of defects found for unit testing. So how do you measure test effectiveness? So the test effectiveness is a measure of the bug finding ability of our test. So in short, it measures how good the tests were. So that if your tests are finding the defects, then that's how we will make sure that the test cases that you are writing are good test cases. So actually it's the picture representation like bugs found in test, new defects found by the user. So total bugs found is equal to bugs found in test plus new defects found in the user. Then the effectiveness is equal to bug found in test by total bugs found. Can you explain defect age and defect spoilage? So defect age is also called a phase age or phage. So one of the most important thing to remember in testing is that the later we find defect, the more it costs to fix. So defect age and defect spoilage metrics works with the same fundamental. That is, how late you found the defect. So the first thing we need to define is what is the scale of the defect age according to the phase. So actually it's like we have a scale of defect age in the picture representation. So defect spoilage is defects from the previous phase multiplied by the scale. So actually it's like sum of number of defects into discovered phase by total number of defects. So we have chapter 7, which is all about the automation testing. So actually the question is what are the good candidates for automation in testing, and does automation replace manual testing? So automation is actually the integration of testing tools into test environment in such a manner that the test execution, logging and comparison of results are done with little human intervention. So as a rule of thumb, do not try to automate an unstable software. So and also do not automate test scripts which will run once in a while, and do not try to automate code and document reviews. Actually those will all cause troubles. So following figures shows what should be automated, should not be automated. It's the third part I have mentioned earlier. So all the repetitive tasks which are frequently used should be automated. So example like regression and sanity and all those things. So which automation tool have you worked with, and can you explain them briefly? So it's all about the user, which tool they have used and how they have used in their framework. So it can be anything. So it's like so the candidates for automation, you have a picture representation like repetitive regression testing, white box, performance testing, smoke testing, code coverage, repetitive load coverage, smoke and load test, and all those things. So actually it's all about the person who is who wrote this document. He's explaining from his point of view that which tool he has used. So actually it's a test complete. So if you are familiar with test complete, then you will easily understand it. Then the next question is how can we use load testing for website? So it's also based on how which tool they have used. So the concept is like the client sends a request to the web server and it gets a response back, and then the tool captures the request and response time. And if you want to make it as a load test, then we will create some virtual users. Then we will try to hit the web server and we will try to capture the request and response time. So actually sometimes they can ask for an example of load testing. So these are all this tool specific. So and actually finally anything about the summary report that you have used. Then what is data driven testing? So actually data driven testing is something like you will have some Excels or XMLs, and the test case will be driven from the data mostly. So if you have a form filling page, so actually you need so many data to be filled in the form. So what the data driven testing will be doing is like, so if you want to run that form 5 times, then you will have 5 rows with 5 different set of values, and the test will be driven by these rows in the Excel. So and can you explain table driven testing, or how can you perform data driven testing using automated QA? So similarly the same question is like how you will be doing it. So what is the concept behind, and what are the libraries or jar files that you are using, and how will you handle single user data and multiple user data, and when you run parallel test cases, how will you handle the data fetch from the Excel? So it's all about how the user make use of the framework. So moving to the chapter 8, the testing or estimation. So what are the different ways of doing a black box testing? So actually there are 5 methodologies. So top down, then work breakdown structure, so guess and gut feeling, early project data, and test point analysis. So what is TPA? So test point analysis is a technique used to estimate test efforts for black box testing. So inputs for TPA are the counts derived from the function points. So actually it's like the small picture representation. So the function points, then the test point analysis, and then finally the function points. So it will start from the white box testing estimation and it will end in black box test estimation. So what is function testing? So function points. So function point analysis was first developed by Alan J. Albrecht in the mid-70s. So it was an attempt to overcome difficulties associated with lines of code as a measure of software size. So actually it's a way to find out the points required for estimating. So actually it's like the points we will be used when we want to estimate for a project or a user story or something like that. So the best way to understand any complicated system is to break the system down into smaller subsystems and try to understand those smaller subsystems first. In a function point, you break complicated system into smaller systems and estimate those smaller pieces, then total up all the subsystem estimates to come up with a final estimate. What is an application boundary? The first step in function point analysis is to define the boundary. So there are internal application boundary and external application boundaries. So can you explain the elementary process or the concept of static and dynamic elementary process? So the FPA is all about breaking huge systems into smaller systems, and software applications are a combination of elementary process. So when an elementary process comes together, they form a software application. So dynamic and static elementary process. So the dynamic elementary process moves data from an internal application to an external application and vice versa. So static elementary process which maintains the data of the application either inside the application boundary or in the external application boundary. So what is FDR, ILF, EIF, EI, EO, EQ and GSC? So these are some of the following points of the FPA. So what is ILF? Internal logic file. So internal logic files are logically related to data from a user point of view. So they reside in the internal application boundary. What is EIF? External internal file. So these files are logically related data from the user point of view. It resides in the external application boundary. So what is record element type? So it is a subgroup element data of ILF or EIF. If there is no subgroup of ILF, then count the ILF itself as one RET. What is data element types? So each data element type should be user recognizable. For example, in the previous figure, we have kept the auto increment field as a primary key. So the subprior field from a user point of view never exists at all. It is only from a software designing aspect, so does not qualify as a DET. What is FTR? File type references. So FTR is a file or a data referenced by a transaction. An FTR should be an ILF or EIF. So count each ILF or EIF read during the process. What is external input? So external inputs are dynamic elementary process in which the data is received from the external application boundary. What is external inquiry? So external inquiry is a dynamic elementary process in which the result data is retrieved from one or more ILF or EIF. In this EP, some input requests have to enter the application boundary. Output results exceeds the application boundary. Then we have external output. So external outputs are dynamic elementary process in which the derived data crosses from the internal application boundary to the external application boundary. Then we have something called general system characteristics section. So section is the most important section. All the previously discussed sections relate only to the application, but there are other things that also to be considered while making software, such as you're going to make an entire application. So what's the performance level the user is expecting? And the other factors are called GACs. So data communication. How many communication facilities are there to aid in transfer of exchange of information? Then we have something called distributed data processing. How are the distributed data and processing functions handled? Then the performance. So it's based on the response time or throughput. Then heavily used configuration. How heavily used is the current hardware platform? The transaction rate. How frequently are transactions executed? Online data entry. What percentage of information is entered online? End user efficiency. Was the application designed for end user efficiency? So online update. How many ILFs are updated by online transactions? Complex processing. Does the application have extensive logical or mathematical processing? Reusability. Was the application developed to meet one or many user needs? And the installation is. How difficult is conversion and installation? Then operational is. How effective or automated are these startup, recovery and recovery procedures? Multiple sites. Was the application specifically designed, developed and supported to be installed at multiple sites on multiple organizations? Facilitate change. Was the application specifically designed, developed and supported to facilitate changes also? So all the above GSEs are rated from 0 to 5. Then VFs are calculated from the equation below. So actually these below lookup tables will be referred to during counting. So EA rating table. Then we have EO rating table, EQ rating table, ILF rating table. Then how we what are the steps used to count the function points? So actually then we have something related to a project. So example how we will be using all these things in a project. So it's like the ILF for the customer, the EI for the customer, EI for the add customer, EI for the update customer, so EO to check the credit card, EQ to display customer credit, then the total of all function points. So that it will be like 31, and then the GSEs, so it will be around 32. Then the VIF like 0.65 plus 22 by 100 is 0.857. So if you are considering the software development cycle, then the phase-wise distribution effort we have also needs to be considered, like requirement 10% of total effort, design phase 20%, coding 100%, and testing 10% of total effort. So how can we estimate the number of acceptance test cases in a project? So the number of acceptance test cases is equal to 1.2 into function points. So actually then we have to consider the GSE acceptance in software industry. So these are the GSE acceptance. Then the FP versus function points versus VAF. So GSE with installation is with 0. So GSE with installation is 0, and then GSE with installation is 5. Then enhancement function points. Send a couple of formulas to calculate the function points. Then how TPA works. So there are three main elements which determine estimates for black box testing: size, test strategy, and product. The size. The most important aspect of estimation is definitely the size of the project. So actually it will be also depending on the complexity. Complexity defines how many conditions exist in function point identified during the project. Then we have the interfacing, and then we have the uniformity. Then second is the test strategy. So every project has certain requirements. The importance of all these requirements also affects during testing estimates. Then we have the productivity. This is one more important aspect to be considered while estimating black box testing. So how do you create an estimate for black box testing? So we are taking an accounting application. So and based on the functionality or the requirement, we will be calculating the function points. And actually, it's based on different screens that we do the calculation. And finally, we will be going through the TPA steps like calculating the function point. So how EOI calculation is done, how EIF is done, how EO is done, how EQ is done, how GSC calculation is done, then finally the total calculation. So how do you estimate then white box testing? The testing estimation derived from the function points are actually the estimates for white box testing. So in the below figure, the mandates are actually the estimates for white box testing of the project, and it will not take into account the black box test estimation. Is there a way to estimate acceptance test cases in a system? So the total acceptance test case equal to total adjusted function points multiplied by 1.2. So actually there is calculate DF, that is function dependent factors, DF calculated. So the function dependent factor is calculated by complexity, uniformity, interfacing, user intensity, and user acceptance. The user importance. So how important is the function factor to the user? Usage intensity. This factor tells how many users use this application and how often. Then the interface. So this factor defines how much impact this function factor has on the other parts of the system. So these are the examples of the interfacing. And finally the complexity. This factor defines how complex the algorithm for the particular function. Uniformity. So this factor defines how reusable a system is. And then we are calculating the QD, that is dynamic quality characteristics. So we have a different formula for calculating the dynamic characteristics. Then calculate TPF for each functions. Then calculate static test points QS. Then calculate total number of test points. Then calculate productivity by skill factors. Calculate environmental factors. So it's based on test aware, test tools, test environment, test basis, development testing, and development environment. Then calculate primary test hours PT, that is TP star skill factor into E. Then calculate total hours, so number of test hours, planning and control hours, and distribution over phases. So that is pretty much about the software testing interview question. So I guess you guys had got some knowledge on software testing interview questions. So these are some of the basic questions that you can expect. So thank you for watching the video. Have a good day. Bye.